Good morning, students. I hope you all are hale and hearty. Students, in my last session, we had seen that based on taste, we can classify the substances into acids and bases. Now, children, there are some substances which are sour in taste are acids, whereas substances which are bitter in taste are known as bases. Now move on. Children, we cannot taste all the substances as they may harm us. There is a possibility it could be quite poisonous for you and you might die. So you cannot really eat or drink everything that you know. Then who is going to tell us that this is whether the given substance is acid or base? So here I will introduce with our hero indicators. Now indicators are of two types. How many types, children? Indicators are of two types. So today we will focus on indicators, right? Let us see. Indicators are of two types, and what it does, it indicates by showing the change in the color. If you will introduce indicator, we will see different types of indicators are there. If you will introduce it to acid or base, it may show the change in the color, right? Based on that, we will decide whether the given solution contains acid or base. Let us see. Now first of all, we will understand how many types of indicators are there. There are two types. We can classify the indicators into two types. They are natural, which we get from the nature, and the second type is synthetic indicator, which we prepare in laboratory, right? Natural indicators, example are China rose, litmus, turmeric, etc. Whereas the examples of synthetic indicator are methyl orange, phenolphthalein. Okay, children, now we will see what different colors it will change if it will introduce to acid or base. First we will talk about natural indicator, litmus. The most commonly used natural indicator is litmus. It is used in every reaction which we do in the lab. When you will grow up, you will find that it is used in every reaction in the lab. Okay. Now what litmus does? Usually litmus solution is light purple color. It is extracted from lichen. Underline, note down this word. From where it is extracted, my dear? It is extracted from lichen. In market, it is available in two colors, red litmus paper and blue litmus paper. In how many colors it is available in the market, children? In two colors. What are they? Red litmus paper and blue litmus paper. If we take blue litmus paper, then what happens? The blue litmus paper does not change its color in a basic solution, or when a blue litmus paper is introduced in base, it does not change its color. It remains blue. Have you understood? Okay. But if you introduce blue litmus paper to acid, what happens? It turns to red color. Okay. Alright. Now we will take red litmus paper. What I have taken? Red litmus paper. If we will introduce red litmus paper to acid, what will happen? Let us see. It will not change its color, or it will remain red there. Will be there no change in color in acidic solution. Okay. But if we will introduce red litmus paper to base, it will change into blue color. Which color, children? It will change into blue color. So you have seen that how does it shows the color in acidic and basic solution. So you can also do, you can take from the market the red litmus paper and blue litmus paper, and you can do here in your textbook. Children, now what you can do, you can open your textbook, science textbook, chapter 5, acid, bases and salts. And you can see in refer activity 5.1. In that activity, some substances are given. One table is also there. Table 5.2 is there. So there you can write, take the substances given in the activity 5.1, and you can introduce it to red litmus, introduce the red litmus paper in that solution and find out what change in the color, what will be the effect of that solution on the red litmus paper, and then you will do the same with solution with the blue litmus paper, and you will find out whether any change in the color is there or not, and then you will write your inference, right? Okay, children. Now move on. The next natural indicator is turmeric. Turmeric, you all know, it is there in our kitchen. Haldi, I think you all know all this. It is in every day we use it in our food, right? Yellow color, that is turmeric. Sometime you might have seen that dress get oil stain if your food fall on your dress, and after that when you wash it, you put on soap on it, what happens? It turns into red in color, and after that if you put water on it again and again, what happens? It becomes yellow again. So what do you find out here? You find out that yellow color of turmeric changes into red, and when you introduce to base, but when it is in acidic solution, it is as it is. Okay. Now talking about next natural indicator, China rose. Now talking about China rose, it is light pink color. Which color, children? It is light pink in color. When you introduce it, let us see the change in the color. When you introduce it to acidic solution, first we will introduce it to acidic solution, it becomes deep magenta. Which color, children? deep. Previously, of what color it was? Light pink. But when you introduce it to acidic solution, it becomes deep magenta, right? Now we will see when we will introduce it to basic solution, what will happen? It becomes green in color. It becomes green in color in basic solution and deep magenta in acidic solution. Have you all understood? Let us talk about red cabbage. Red cabbage is, it is not given in your textbook but extra. It is magenta in color. When it is introduced to acidic solution, it turns to red, but introducing to basic solution, it turns to yellow color. Okay, all right. Now let us talk about, this was all about the natural indicators. In natural indicators, we have seen the first was litmus indicator, then the second we talk about turmeric, then third China rose, right? Now synthetic indicators. Synthetic indicators, as I told you, it is prepared in the laboratory. Mainly two are here, phenolphthalein and the next one is methyl orange, right? In synthetic indicator, we have phenolphthalein and methyl orange. Okay, phenolphthalein is a kind of magic. It is usually always in colorless state, right children? It is generally colorless state. When you introduce to acidic solution, when you will introduce the phenolphthalein to acidic solution, it remains colorless, no change in the color, right? It remains colorless. When you introduce to basic solution, then what happens? It becomes, see, pink color. Which color, children? Pink color. So now phenolphthalein, when we introduce it to acidic, of what color it is? It is colorless. When we introduce it to acidic, it is remain colorless. But when you introduce it to base, it becomes pink. Okay. So basically, if any solution you have put on phenolphthalein, if there is base in it, it will turn pink. But if it is acidic, it is colorless. That we have seen just now, right? Now moving on, talking about methyl orange. The next synthetic indicator is methyl orange. As the name suggests, the natural color of methyl orange is orange color. Which color, children? Orange. If you will introduce it to acidic solution, it will be red in color. It will become red. But if you will introduce it to basic solution, it will be yellow in color. It will turn to yellow color, right? Have you all understood? Now we have learnt about, till now we have learnt about acids, bases and indicators, right? So quickly note down some points. Summary points are given here, so you can note down it and read it afterwards, right children? Children, I hope you all have understood about it. Now it's time for activity. Now you can do it by your own. Just open your textbook, science textbook, and refer table 5.2 given on page number 51, and you will see some substances are given on activity 5.1, like tap water, detergent solution, aerated drink, soap solution, shampoo, common salt, sugar solution, then vinegar, baking soda solution, milk of magnesia, washing soda solution, lime water. So you have to make the solution of all this in, if possible, make the solution in distilled water, right? Or whatever are easily available to you, you can take, not necessarily to take all these things, whatever are available to you, that you will take, and then you will record your observation. You can do the you can use the take test with the, first you will, as I had told you, with the litmus paper, the same you will repeat with the turmeric, right children? So for making the turmeric indicator, what you will do, you will take a tablespoonful of turmeric powder, add a little water and make a paste. Then make turmeric paper by depositing turmeric paste on blotting paper. You will take a blotting paper, it is easily available. If you will not get the blotting paper, you can take a tissue paper or filter paper and drying it, sukha dena usko, right? Then cut thin strips of the yellow paper obtained and put a drop of, then you will take the all solution mentioned in the activity 5.1, take the solutions and find out the effect on this turmeric paper, right? So this you will do. Then refer table 5.3 given on page 52. Here you will use China rose as an indicator, China rose solution. How you will prepare the China rose solution, children? You will collect some China rose. You know na China rose? In Hindi what do we call it? Gudhal. You will collect some China rose petals and place them in a beaker. Add some warm water. Don't take the boiled water, right? So add some warm water. Be careful by using. Take some. You will do under the guidance of any elder one. Then only do. Don't do it alone. Take some warm water. Keep the mixture for some time till water becomes colored. Use the colored water as an indicator. Got it, children? Now this colored water you will use as indicator. China rose indicator. Add 5 drops of the indicator to each of the solution given in the table 5.4, and then you will record your observation, right? Table 5.5, that I will advise you not to do, because whatever the solution are given there, it is quite harmful. A lot of care you have to take, so I will advise not to do that. We will see here quickly, we will see what is it. Activity 5.4, you have to take some acids given there: hydrochloric acid, sulfuric acid, nitric acid and acetic acid, and then you have to find out what will be the effect on litmus paper, then effect on turmeric paper, then effect on China rose solution. Have you all understood this? First we will see if you will take the dilute hydrochloric acid, then what will be its effect on litmus paper. Okay, children, you can see the change in the color, you can note down. Then observe here what will be the effect on turmeric paper. We'll take the turmeric paper and then we will put it on it, a litmus paper, and you can see what effect will be there. Then you will take China rose solution that I told you how to prepare it, and then we'll see China rose solution. If we will put the dilute hydrochloric acid, what will happen? So you have seen all this, but I will advise not to perform this because we have to take a lot of care while handling laboratory acids and bases, because these are corrosive in nature and irritating and harmful to skin, right children? So this was all about the indicators, and that's the end of this session. In my next session we will discuss about neutralization, right? Thank you.